This is a video series on the unit solid state physics of UG level physics. You can check out other video of the series. So let's begin.
Hello everyone. In this session we will be studying about free electron theory of metals. Okay. So we will be studying some theory related to the electron motion. So we will go step by step. First let us go to some history of development of the free electron theory. First it was the classical free electron theory. So what was the classical free electron theory? It was actually developed in the initial phase. At the starting there was classical theory. Okay, so on the basis of that classical theory, like Newton's equations and classical phenomena, the electron motion was described in a metal. So it was developed around 1900. It is mainly considered to be developed by two scientists, Drude and Lorentz. Okay, so we also call sometimes them Drude and Lorentz theory. So what it was considered that, what was the main concept of this Drude and Lorentz or classical theory? That valence electron are loosely bound, becomes free at high temperature or at ordinary temperature. As temperature increases or as temperature increases, becomes free. So this conducts electricity. Okay, and they obey classical law, Newton's equation. So we will be studying mainly this theory in details in this session. So later on it was seen that some of the phenomena can be explained, but it has many drawbacks or failures. So on the subsequently quantum theory was developed. That was quantum free electron theory. So quantum free electron theory. Okay, so it was actually developed around 1928. Okay, it was mainly first this quantum here, it was developed by Sommerfeld. Okay, Sommerfeld, quantum theory of electron conduction. This is Sommerfeld, and here quantum theory is used. So here classical concept are used, here quantum theory is used related to the electron motion. Okay, so next, subsequently, this theory also was found to have some drawbacks or demerits. This was subsequently further modified, and we have the zone theory, or which we call band theory of solids. So band theory is the ultimate, which uses quantum wave mechanical description. Okay, here mainly particle nature is considered, but here wave mechanical, that actual Schrodinger equation and actual quantum wave mechanical theory was used. It is also developed around 1928. It is mainly extended by Bloch. So we will study later on the band theory of solid, where Bloch theorem, Bloch formulation is used. Okay, Sommerfeld we will not study. This is just for your knowledge. So these are the history or progress in the electron conduction in metals or in solid. So we have classical free electron theory developed by Drude and Lorentz around 1900, which considered the valence electron to become free at temperature, at some ordinary temperature or high temperature, and conduct electricity. And main concept is it is free, that's why free electron, and it follow classical law. Then quantum theory comes into play, and Sommerfeld used quantum theory to describe electron conduction. Then later on it is further modified to get greater picture or more correct explanation using band theory of solids, which used quantum wave mechanical phenomena, or quantum wave theory or wave mechanics, and it is mainly developed at the initial phase by Bloch. Okay, later on it is modified by many other scientists. So it is mainly started by Bloch. So okay, so these are the history of free electron theory. Now we will move to our actual topic, that is Drude and Lorentz theory or classical free electron theory. What are the formula? You already studied something about electricity. A few of the formula you have already studied in lower classes like HS, secondary classes. So here directly we will be using the formula and some definitions. We will be doing this. Not much calculations are there. So only we have to know the basic idea, its merits and demerits, or its achievements and failures. Okay, let's go to the next slide. Okay, so now we move to our actual free electron theory or the classical theory or the Drude Lorentz model. Okay, so we have to first study the assumptions. What are the assumptions? These are very easy assumptions. So one of the assumption is that the valence electron of the atoms in a solid, or say in metal, here we are considering the metal will have a loosely bound electron outermost shell. The valence electron in atom in solid are loosely bound and becomes free at ordinary temperature. Okay, such free electrons in a metal move freely throughout the volume. এখানে কি হয়, এই লুজলি বাউন্ড ইলেকট্রনগুলো লুজলি বাউন্ড ইলেকট্রনটা যখন ডিটাচ হয়ে যায় তখন আয়ন কোরটা ফিক্সড থাকে আর ইলেকট্রনটা ফ্রিলি মুভ করতে পারে. দিস উই হ্যাভ অলরেডি স্টাডিড ইন কেস অফ মেটালিক বন্ড. সো এই ফ্রি ইলেকট্রনগুলো প্রতিটা অ্যাটম থেকে একটা মেটাল বা সলিডে 1 মোল মলিকুল 1 গ্রাম মোল যদি নাও, এখানে অ্যাভোগাড্রো নাম্বার হিউজ নাম্বার অফ অ্যাটমস থাকে, তো হিউজ নাম্বার অফ ইলেকট্রন ফ্রি হয়ে যাবে, সেগুলো সব মুভ করতে থাকে সলিডের ভিতরে থাকে. আয়ন কোরগুলো ফিক্স থাকে থ্রু the solid, whereas ion cores are fixed. ঠিক আছে, so these free electrons constitute what we call free electron gas. Okay, এই যে লুজলি বাউন্ড ইলেকট্রন যেটা ফ্রিলি মুভ করে কোনো পার্টিকুলার অ্যাটমের মধ্যে ডিটাচ থাকে না, থ্রু আউট দ্য ভলিউম মুভ করে থ্রু আউট দ্য ভলিউম, এগুলোকে আমরা বলি ফ্রি ইলেকট্রন গ্যাস. ঠিক আছে, ওকে, and this loosely bound electron which moves through the solid are called conduction electron. Conduction electron means which conduct electricity. Okay, this is one of the assumptions. So main assumptions, this is very easy, you have studied this also in chemistry or secondary level physics, that valence electron when atom are loosely bound, so at all room temperature or higher temperature these get detached by getting thermal energy, so these all atom contributes the valence electron, they move throughout the solids and they are free to move, so these are called free electron gas. Now second assumption is, here this is classical. Okay, so this is classical equation. So okay, so this free electron gas obeys Maxwell Boltzmann velocity distribution law and obey kinetic theory of gas. এখানে ম্যাক্সওয়েল বোলসম্যান যেটা দেওয়া ছিল কেন, বিকজ ফ্রি ইলেকট্রন আর assumed to move in a solid similar to gas molecule in a enclosed chamber. So it is temperature dependent property. At a particular temperature gas molecule will thermal energy pabe. So this is mainly associated with the thermal behavior. So temperature দিলে বেশি টেম্পারেচার দিলে বেশি মুভ করবে, কলিশন হবে, এগুলো হবে। তো ইলেকট্রনগুলো এরকমভাবে অ্যাজিউম করা হয়েছে যে ভলিউমের মধ্যেই থাকবে, সলিড ভলিউমের মধ্যে যতটুকু ম্যাটার সলিডের ভলিউম নেব, কিন্তু ফ্রিলি মুভ করবে সিমিলার টু gas molecule depending on temperature. So they will obey MB statistics and kinetic theory of gas. We will use the kinetic theory formulas. Okay. So the electrons can collide with ion core elastically. So there is no loss of energy. So here electron collision are ignored. So this is called independent electron approximation. তো নামটা মনে রাখলেই হবে আমাদের, যে ইলেকট্রনের কলিশনটা এখানে ইগনোর করা হয়েছে। তো ইন্ডিপেন্ডেন্ট ইলেকট্রন মিন্স ইলেকট্রন আর নট কনসিডার, one electron is assumed do not come with the other electron nearby. So this is actually highly approximate. Electron will obviously collide with the electrons. They will collide with the ion core and also with the electron, but here this is ignored. So this is independent electron approximation. Okay, now fourth assumption is when an electron collide with an ion, its path changes and again it collide with another ion. So in between two collision of electron ion, the electrons move freely without any interaction in a straight line path. ঠিক আছে। সো দুটো কলিশন, এখানে একটা ইলেকট্রন আসলো, এসে এখানে কলিশন করলো, ঠিক আছে। ইলেকট্রনটা এসে যদি এখানে কলিশন করে তাহলে ইলেকট্রন এইদিকে ডেভিয়েট হলো, তারপরে আরেকটা আয়ন কোরের সাথে মিলে এইদিকে ডেভিয়েট হলো, তাহলে এই একটা কলিশন, ফার্স্ট কলিশন, এটা হচ্ছে সেকেন্ড কলিশন। তো এই দুটো কলিশনের মধ্যে দিস ইজ ফ্রি ইলেকট্রন, মুভস ইন এ স্ট্রেট লাইন। ওকে, তারপরে আবার কলিশন হবে, আরেক দিকে যাবে, ঠিক আছে। সো দে অলওয়েজ ইন বিটুইন টু কলিশন দে হ্যাভ free path. So actually you have studied earlier the mean free path like this. Okay, let's go to the next slide. Next assumption is when electromagnetic field is applied, electromagnetic field যখন দেওয়া হবে এটার মধ্যে কি হবে, the trajectory will be given by Newton's equation or law. So এখানে ক্লাসিক্যাল ইকুয়েশন ইউজ করা হবে। সো এই জন্য এটা হচ্ছে ক্লাসিক্যাল থিওরি। ওকে, একটা তো হচ্ছে MB statistics obviously, and kinetic theory, this is obviously again given by Newton's equation. So here the motion of electron, when electric field is applied, electron will move in a direction opposite to electric field. Okay, and the path or motion will be given by Newton's law, means force equal to mass into acceleration. Okay, now we will define another term, tau, the relaxation time. What is the relaxation time? Or you can also say it collision time or mean free time. So all this you have, I think you have studied. So relaxation time we will use mainly relaxation time. So what is relaxation time? It is average time between two consecutive collisions. So as we have mentioned in earlier points, in point 3 or point 4, that in between two collisions electron moves freely in a straight line path. So there will be different type of many collisions. So average time will get between two collision where it is free. So average time between two collision where electron moves freely in straight line path. So okay, so the in between two collision path will be different, time will be different, but on average we will find the average value, that is the relaxation time. So relaxation is a time. What is the time? Time between time of free travel between two collision. It is average value. Okay. Next, so if time tau is the relaxation time, so tau in tau time, how many collision occurs? One collision, because it started, suppose it started from here, electron, and it moves here. So this time taken will be t seconds. So how many collision? One collision. From there it will again move there. Okay, second. This will take reference. So from starting from this, electron moves. So it will get collided. Then so first collision time taken is tau second or average time. So in 1 second, how many collision? 1 by tau number of collisions. So per second number of collision is 1 by tau. So you should remember this. In per second number of collision is 1 by tau. Okay. Now also we define it another term, that is free path, or you can say mean free path. This also you have studied in case of kinetic theory. So mean free path is the path traveled, average path traveled between two subsequent or consecutive collisions. Okay. So in lambda second, in tau second, lambda meter length is, so in tau second distance traveled is lambda meter. If we take SI unit, so lambda meter. Okay. Now from kinetic theory, root mean square velocity of electron at temperature T will be root 3 kT by m, where T is the temperature, m is the mass of electron. Okay. K is the Boltzmann constant. K is the Boltzmann constant, 1.38 into 10 to the power minus 23 joule per Kelvin. Okay. And electron mass is 9.1. So this is Vrms value from kinetic theory. Now here we will use the notation Vth. Actually it is same. So why we use the notation Vth? Vth is thermal velocity. Why we call this thermal velocity? Actually this we used in case of electron in metal. In gas we use Vrms, but here we will use Vth. Vth is the thermal velocity because electron is gaining energy mainly due to temperature. So this we consider without any electric field. Okay. So normally electron will move due to temperature or thermal motion, that is the thermal velocity. So now, so we can relate this tau, lambda and velocity. How we can relate? How we can relate this, all these things? So Vth, velocity will be, what will be velocity? Velocity will be distance by time. So lambda by tau. So this relation you remember. This relation also you remember. This is suppose 1, this is suppose 2. Okay. So this will be required. So Vth or Vrms, you remember the same, just we have changed the notation for the sake of simplicity. In case of electron motion, we will be using Vth, which is the thermal energy related to temperature. Okay. So lambda is the mean free path, tau is the mean free time. Okay, or relaxation time. Okay. Okay. Now at some temperature T, electron will move randomly and will get scattered by ion core in all direction. So this is normal. In random case, randomly and uniformly. So when there is no electric field or no external force, electron will move due to temperature and it will be scattered and it will move in all direction. Okay. So uniformly, so suppose you metal, all direction, some electron will move along this, some will move along this, some will move along this. So vectorially we have no net displacement. So no displacement means no current in absence of electric field. Due to random motion, all electron will be scattered in all direction by all ion uniformly, so we have no net current. Okay, but when electric field E is applied, so these all are on the free electron theory. There's basically we studied in secondary level. Quantum level we studied in higher level. So in your theory we will mainly study classical theory. So free electron, when electric field E is applied, a force, additional force minus E will act on electron. So force E will act on electron, which accelerates electron further. So now along the direction of field, not along, it will be opposite, because electron, you know, by application of electric force will be in opposite direction to the electric field. So if electric field, now if electric field is given, electron earlier it was moving randomly, now it will move in uniform direction, say in this direction. If electric field is applied along this direction, okay, electron will move in opposite direction, and we will have, which we call drift velocity. Drift velocity means earlier electron was scattered in all directions, there is no displacement, but now due to electric field, all the electron will try to move opposite to the electric field. So now there will be some kind of, so earlier it was scattered in all direction. Now if we apply the electric field, what will happen? They will slightly displaced, all will now try to move opposite to the electric field. So now here we will have a net displacement or drift, that's the name, drift velocity. So some will get obviously cancelled because all electron cannot follow the path opposite to electric field. Some electron will easily follow, or so net vector, there will be no cancellation, net displacement will be there, so net current will be there due to drift velocity, which we define as Vt. Okay, so how can we find? We will use Newton's law. We can use Newton's law to find drift velocity. So force is equal to mass into acceleration. Okay, so we know force is minus E. Okay, and again minus, if we consider, okay, we can consider, so m by E vector, so minus E by m, we can consider what will be E, electric field. Okay, so this we already know. Now drift velocity is the mass into acceleration into relaxation time. Now drift velocity, here we consider that when electric field is applied, it before the collision, the relaxation time we consider. Okay, so the free path that it travels, so the time taken will be tau. Okay, so in this relaxation time, additional velocity will be provided, so that's why we use the time tau. So now it will be simply E by m E tau. Okay, so this is the expression for drift velocity. Now if we take drift velocity and electric field along the same direction, so we will ultimately get Vd equal to minus E by m tau. So we take the positive magnitude, so negative, electron has sign negative obviously because it will drift opposite drift, this you know. So just for convention we can take positive sign for finding the magnitudes. Okay, so these you should remember, this is equation 3. Now from here various relation we will find out E tau by m into E. We will modify like this and we will write it mu E. So what is mu? Mu is written as E tau by m. So what is this? This is called mobility. Okay, so what is drift velocity? Drift velocity is the average velocity with which a free electron get drifted over and above the thermal velocity. Okay, it is over and above. Thermal velocity is always there due to temperature, but this is extra. So this is the average velocity by which electron get drifted over and above the random motion under influence of external field. Okay. And mobility, what is mobility? So e tau by m, this is mu e, so this is vd by e. So how we can define mobility? This we also studied. Mobility is drift velocity per unit electric field. Okay. So this you also remember. This you also remember. This you also, all these we can take equation 3, 1, 2, 3, 3, 1, 3, 2, 3, 3 or 3 ABC like this. So all these are basic relations, you know, Vd tau E by m tau. How we relate this? A tau mass into acceleration, Newton's law we use because we consider their classical theory. Okay, all clear? Okay. Now we'll find some basic formula. Current density. What is current density? Current density is current per unit area flowing normally to the cross section. You already have studied, I think, this in class 11 or 12. So if you have some area, cross sectional area, current is flowing normally through this. So current per unit area is this. Okay. Current is charge by time. You know, total charge by total time. So this all things you know. So we'll use this formula J, or you can use small j or capital J, anything. We know from classical theory this relation is minus E N V D. What is N? N is the number density of electron per unit volume. Okay, and minus E is the charge, so NeV. Okay, now minus NeVd, drift velocity. Just now we have found out what was the drift velocity. Drift velocity was minus E tau by m. This is just now we have found out in earlier equation 3. So this will multiply. So what we will get? We will get n e square by m. So n e square m tau into electric field. Okay. So now we simplify this. This will be n e square tau by m e. This is one of the relation. Now we will subsequently modify. Now we already know what will be tau, n e square by m. If we replace the tau in earlier equation number 2, what was the relations? Vth, drift velocity is lambda by tau. So tau will be lambda by thermal velocity, okay, into electric field. This again we can modify, n e square lambda by m. Okay, what is Vth? Again Vth is root 3 kt by m. So here we will put the reverse one. So it will be m by 3 kt into e. Okay, so it will be ultimately n e square lambda by 3 m kt into e. So all these relations, this is one relation, this is another relation, this is another relation. So all these are just simplifications. So you have to remember these formulas. So now we write, where you have taken this, now we can write J equal to sigma e. If you like this, so everywhere it is E. So whatever E except E, whatever is there, that will be sigma. So sigma over, from first relation sigma will be n square tau by m. From this it is n square lambda by m Vth, and from third it will be n square lambda by root 3m kt. So all these are relation for sigma. So what is this? This is conductivity. Okay, conductivity. Okay, now we define another term, 1 by rho. Rho is the resistivity. So what will be 1 by rho? 1 by rho is sigma is 1 by rho. Rho is E by J vector. Okay, and it will be exactly reverse of that one. N square tau m Vth by n square lambda root 3 m kt by n square lambda. So just you reverse the sigma part. So in terms of this, if you write this, this will be E equal to rho J. Conductivity, resistivity. Okay. These are the property of, okay. So rho will be Vj, this will be 1 by sigma. Okay. So this one. So from this relation, one important thing that we get from free electron theory, one of the results, you see, sigma is proportional to n and sigma is inversely proportional to 1 by root t. So this will imply rho is proportional to root t. So this predict square root dependence on temperature and direct square root, inverse square root dependence, direct square root dependence. This is due by Drude-Lorentz theory. Actually here we want to find the temperature dependent property of electron conduction. So this is one of the results, resistivity or conductivity we get from this. Okay. So another relation also we can get, E equal to rho J. If you take E and J are parallel, so E will be V by L, rho J will be current per unit area. From this V by I, if we rho L by A, this we defined as R. This is resistance. So V by I resistance. Now if you see, if temperature is constant, if T is constant, it's very easy. If T is constant, everything is constant, rho is constant. If rho is constant, L is constant, length of the sample, area of the sample. So V by R equal to R will be constant. So what is this? This is Ohm's law. So if you are asked to find Ohm's law from free electron theory, you do this. That we know J is this, J is this. So you substitute the earlier formulas, mean free path, mean free time or relaxation time, thermal velocity from kinetic theory. From this you find an expression for sigma. This is dependent on temperature. So if temperature is fixed, you will get temperature constant. Also number density is constant for electron. Number density is constant for metal because all electrons are loosely bound and they appear in the conduction. This is one of the assumptions that all free electron contributes to conduction. So it is almost maximum electrons are contributed. So n will be almost fixed. So it will be, if temperature is fixed, rest of the things will be automatically fixed. Number density will be fixed because whatever with the loose electron, that will be there. Depending on temperature is fixed, all things will be fixed. So V by I will be fixed. That is the Ohm's law. That V is proportional to I. That is the Ohm's law. Okay. So this, okay. Let's now we will just summarize what are the achievements of Drude-Lorentz or classical field electron theory and what is the failure. Okay. So what are the merits or achievements of DL theory or Drude-Lorentz theory? One of the is it can explain electron or electrical conduction in metals. Then it explains thermal conduction in metal. We have not studied the thermal conductivity. We will study in the next class. Then Ohm's law is obtained from this theory. Okay. Then another theory we will study, which is Wiedemann French law. Okay, is obtained. So we will study this Wiedemann French law and the thermal conduction. These two are related. We will study in the next class. So for the just for revision, you remember this. Okay. This also explain opacity and luster of metals. This you have studied in electronics. Why metal are opaque? Why it is luster? Opaque. Why opaque? When electromagnetic field falls on a metal, the free electrons are there. They absorb all the energy. So there is no passage of energy. So it appear opaque. And why luster? Then once electron get excited, they release the energy and they go into the ground state after some time. So this energy are radiated in all directions. So they appear luster. So these are few of the merits. Now what are some of the failures? These are very important because these are asked in the exams. What are the achievements and failures? What is the failure? Cannot explain electrical conductivity of semiconductor and insulators where there are very few free electrons. যেখানে খুব কম ইলেকট্রন আছে যেমন সেমিকন্ডাক্টর আর ইনসুলেটর, এখানে কি করে ইলেকট্রিক্যাল কন্ডাকশন হতে পারে সেটা এটা এক্সপ্লেন করতে পারে না, কারণ ফ্রি ইলেকট্রনে থিওরিতে ধরা হয়েছে প্রচুর পরিমাণে ফ্রি ইলেকট্রন থাকবে, তারাই করবে। ঠিক আছে, free electron predicts sigma proportional to 1 by root t and rho proportional to root t. Okay, but these predictions fails with actual experimental results. Actually it is seen that rho is proportional to t rather than t. Okay, then theory fails to explain heat capacity of metals. How specific heat or electronic specific heat varies, or why it varies, or how it depends, this cannot be derived from free electron theory. Okay, so there are many other so you remember this few of the things, that heat capacity cannot be explained in metals. So temperature dependence of rho and sigma is not correctly predicted, and it cannot explain the semiconductor insulator electrical conductions. Okay, so these are the few demerits you remember, and merits are it explain electrical conduction in metals, it explains thermal conduction also, Ohm's law can be also obtained, Weidmann-Franz law is also obtained, opacity luster of metal can be explained. So okay, so from this part we have studied, you revise this free electron theory. So here mainly what are the assumptions, what are the few results, and what are the demerits you remember. In the next lecture we will be discussing about thermal conduction, this property thermal conduction, some direct formula. Here also we will use kinetic theory, direct formula we will write, and from this we will derive very important results which may be asked in the exam. পরীক্ষাতে আসতে পারে Weidmann-Franz lawটা কি। সো এটা থার্মাল কন্ডাকশন ইলেকট্রিক্যাল কন্ডাকশন দুটো মিলে একটা ল আছে, সেটা এখানে আমরা ডাইরেক্ট থার্মাল কন্ডাকশনের ফর্মুলা ইউজ করবো, কাইনেটিক থিওরি, সেখান থেকে Weidmann-Franz লটা বার করবো, বাস নেক্সট ক্লাসে ওটা করবো, আর এক দুটো নিউমারিক্যাল করবো, কারণ সময় নিউমারিক্যাল আসে পরীক্ষাতে। ওকে, থ্যাংক ইউ।